Most of the faults in overhead systems are arc faults caused by temporary conditions. Often they disappear automatically when the line is disconnected. Therefore, the use of automatic reclosing is usually advisable. Auto-reclosing can minimize the disconnect time resulting from electrical faults. In the graphic, you see the signals for the automatic reclosing. When a fault is detected on an open line, the relay trips and the line is disconnected. Once a dead or delay time has elapsed, the line is automatically reconnected. If the fault persists, the line is disconnected again. Depending on the number of reclosing cycles, the line will remain disconnected or a renewed attempt will be made to reclose the line. To test the auto-reclosing, we insert the Autoreclosure test module in the OCC file. In this example, we will test an automatic reclosing with only one reclosure cycle, but remember that you can test up to 15 cycles in the test module. According to the relay under test, the extended zone Z1B is enabled before the first auto-reclosure. This means that the relay trips instantaneously for faults up to 120% of the line impedance. Now we start out with the local hardware configuration. The voltages and currents are required for this test. Additionally, we need the protection relay's trip command and the circuit breaker close command. In the first tab, you can define the fault settings. In our example, we will simulate a fault within the extended zone so we can check whether this zone is active or not. Therefore, we choose the impedance set mode with constant current so we can locate the fault at 100% of the line impedance. We set the fault angle to the line impedance angle, that is 64 degrees. We can also use the link to line angle option. If you change the line angle in the real block distance of the test object, the fault angle will adapt automatically. Remember that the test current must be above the pickup value of the distance protection function. Here you can define the duration of the pre-fault state. This is useful when the auto-reclosure function presents a blocking time after the last circuit breaker close operation. Then, the pre-fault duration must be greater than this blocking time. With the time limits during test, you can specify the maximum period of time that the module will wait for a trip or a circuit breaker close command respectively. Keep in mind that the time in the circuit breaker close entry field has to be higher than the dead time set in the relay. Otherwise, the test will be stopped before the relay sends the close command. The next tabs are the unsuccessful sequence and the successful sequence. These two tests are connected. It is only necessary to configure the test in the unsuccessful sequence tab, and the information is then captured into the successful sequence tab. If you are not interested in performing any of these two tests, just clear the box to disable it. The drop-down menu in the first column presents a list of possible events to be measured. In our case, the first event will be the trip. Regarding the assess mode, we take the time option. This way, we can enter the nominal expected time and the tolerances specified in the manual for an automatic assessment of the results. It is also possible to simply record the signal or to check whether the signal is detected or not. The second event is the dead time, which is set to 500 milliseconds in our relay. An unsuccessful sequence implies that the fault is persistent, forcing the relay to trip again. In our relay, the zone 1B is deactivated after the auto-reclosing to ensure selectivity in the network. Consequently, a relay located at bus bar B is able to trip in the event of a fault beyond this location. For this reason, we expect our relay, which is located at bus bar A, to trip at the time of zone 2, that is 400 milliseconds. Because we are testing one autoreclosure cycle, no CB close is expected after the second trip. If we take a quick look at the Successful Sequence tab, we can see that all the settings are taken from the Unsuccessful Sequence tab automatically. Naturally, this sequence does not include a second trip event. In the Assessment Settings tab, you can enter the start and stop conditions for each measurement. The definition of the dead time might depend on the relay. For some relays, the dead time starts when the trip signal goes from 0 to 1. This suits the relay under test. For some others, it starts when the trip signal goes from 1 to 0. The stop event happens when the close command goes from 0 to 1. When the test is started, the module begins with the successful sequence and proceeds with the unsuccessful sequence next. After the test is completed, you can check the associated time signal view for each sequence.